Here we're going to use the change of base formula to solve an equation. We are asked what is the solution of the equation 2 to the x power equals 7, and we're told to express the solution as a logarithm and then evaluate and round to the nearest thousandth. So let's take our 2 to the x power is equal to 7. We're going to see that that's in the form of b raised to the x equals y. We are going to convert that to a logarithm. So we're going to say log of base b, which in our case is 2. The y value would be our 7, and that would be equal to x. So our b was 2. We'll just highlight this so we can color code it. Let's go back to where we want to be, and then our x values. Okay, from here we now have x being equal to a log base 2 of 7. In the previous video, we used the change of base formula. We're going to do the same thing here. These problems are really not much different than the previous ones. You're just starting with an equation. So this would become the log of 7 divided by the log of 2. That would be equal to x. And then we're going to approximate that to the thousandth. So we'll take our calculators. We're going to do log 7, close our parentheses, divided by log of 2, close our parentheses, and hit enter. So 1,000, 3 decimal places, 2.807. And that's it. That's all we're looking to do here. You do have the option of doing the log 7 and log 2 separately. I'll show you that real quick. But numbers 22 through, this goes out to 28, they're done the same way. You're just going to, and they're all in the same form, so it should be an easy process to repeat. Just get in that habit, that routine, and you should not have much issue with 22 through 28. But let's say you, instead of typing the 7 and the 2 in together, you could do log 7, get an answer, log 2, get yourself an answer, and then you might round here, so you might do 0.845 divided by 0.301. Notice that your number is pretty close. For our purposes, it actually rounds out to be the same, 2.807. Just know that if you do them individually, you might be off by a decimal place or two. Since we are approximating, it's not a big deal. If you did this and got 2.806, don't panic, right? You're within 1,000th decimal place, so you're probably doing it correctly. It was just some kind of rounding variation or variance. But change the base formula, use that to solve the equations, shouldn't have much issue.